Oh hey, I didn't see you there. I'd like to welcome you to Bro Science. We're playing a little game of Swollopoly.
You landed on the bench press. Give me 500 gains.
Alright. And I'm Lars.
I'm Will.
And I'm Billy the Scientist.
Shut up, Billy.
Ah, no one respects science!
Welcome to church. The most important part about bro science is that lifting is an ideology. The weight room, aka church, is where we go to worship. This is because lifting is religion. Everybody comes here every week to do the same thing that they did last week. Also, all religions have a place of worship, whether it's a church, a mosque, a temple, a sacrifice spot in the middle of the woods, doesn't matter. But lifting has the weight room. The Church of Iron. We have had our Savior die for our gains. Go to church.
Okay, so now we get into the most important lifts. We got power clean, the most important. Bench, the most alpha lift. And squats, the most skipped lift. Now, squats are hard, tiring, and they aren't arms, chest, shoulders, or even back. You go to the squat rack to get some Now, squats are only worth it if you already have a massive upper body.
See you in church.
Now, breaking down Will's squat, we can see when the bar is on Will's shoulders, the velocity is constant. Now, when the velocity is constant, we know that acceleration is equal to 0. Normally you think, well, if F equals ma, and a is equal to 0, force is equal to 0. There's one major problem. There's a lot of mass. So with that lot of mass, we get a lot of gains. Breaking down the squat.
Father, forgive me for these gains I'm about to receive. That's right, what's up?
Alright, so now we're going to break down the bench press. A very common and useful exercise. Now the key to this is actually making sure that the bar does not rotate. You're going to want it to be in static equilibrium. You're going to have 2 points on the bar, which are your hands. They're going to be equally spaced from the center of mass of the bar. This means that they have the same lever arm. And as long as you apply the same force at the same distance from the lever arm, you are not going to have these weights, which have their own mg, outweigh the normal force. Therefore, the sum of the torques in the system will be 0, and your angular acceleration is also going to be 0. Now, if you want to find the normal force, it's quite simple. We see that 765 pounds, which is how much Will can bench press, equals about 350 kilograms. 350 kilograms, well, that's both of these. We'll just say that this is 175 kilograms for each, times 10, assuming acceleration is not 9.8, because that's a messy number. You'll have 1,750 newtons having to be applied as normal force per arm. Thank you.
Deltoid raises. Sure, you could get an awesome pump in and use lever arms with a lighter weight. Or cut the lever arm and make the weight heavier. Yeah, you wanna beat me?
Alright, disciples, now we're going to break down the deltoid lift. Now this is Lars's beautiful arm, and we're going to assume that it has a mass of 0. Just for the sake of saying, the rotational inertia, calling this a particle, is mr squared. Now, we're going to sum the torques, calculate I using mr squared, and solve for the angular acceleration of the system. Now we're going to start by writing that. Sum of the torques equals I alpha. Now the torque is just going to be the force times the lever arm. Now the force, we know, is 10 kilograms times 10 meters per second squared times, let's just say this is 1 meter because he has very long arms. 1 meter. This is 100. That's the torque equals I, which is mr squared, times alpha. Now, plugging this in, alpha is going to be 100 divided by the mass, which is 10 kilograms, times the radius, which is 1 meter squared. This is going to equal 10 radians per second squared. Thank you.
Rotate. The day that you start lifting is the day that you're forever small. Lift with small people so you feel bigger.
Okay, now let's move on to cleans. Cleans can be one of the most alpha things you can do in the gym, or not. It depends if you can do it. It's like shooting hoops. If you make all your buckets, then you are Steph Curry, and then this random girl will come over you. But if you're not, or if you can't, then you're a disgrace. Now, cleans are very intricate, as you see, it has many moving parts. Now, the idea is to have it in a straight line the entire way so you get maximum gains. Double pump. Reps for Jesus. University of Wisconsin. Dumbbell door.
Oh, hey, I didn't see you there. We're going to break down the power clean, and we're going to talk about work, change in kinetic energy, and power, which is the work divided by the time. Let's start off with work equals the change in kinetic energy. Change in kinetic energy means it's the final kinetic energy minus the initial. Now we know the power clean is going to start off low. Initial is going to be 0. So the work is just going to be the gravitational potential up at the top. That is, work equals mgh. We're going to use the mass of 225 kilograms. We're going to use g as 10 meters per second squared, and our height is 2 meters. Now this comes out to 5,500 joules. That's work, change in kinetic energy. Now we're going to go over power, which is the work divided by the time. That's going to be 5,500 joules divided by how many seconds? 2 seconds. 2750 watts. That's the power clean.
Pro tip. If you want more gains, you have to have energy into the system by spinning weights. If you use the formula E equals mc squared, then you would know that more energy equals more mass and more gains.
Stand in the back, flex in the back.